about that. So what we're up against here is we're trying to learn something about the sizes of atoms when they form ions.
Stop moving it around. Stop critiquing. Let's do a daily special.
Oh, this is so hard.
Are you going to go around the front?
No.
Here we go again.
We have to do the necessary pan around the room, see who's here.
You're going so fast. You're going to now.
Okay,
Oh.
so anyway, when atoms form positive ions, now listen, atoms, when they form a positive ion, will lose electrons, and so you've got the same number of protons in the middle, but now you have a different number, a smaller number of electrons around it. That means those remaining electrons are going to get drawn in more tightly. So for all positive ions that form, the atoms get smaller. Ions are smaller than the atom was before. Atoms always become smaller when they form positive ions. And here's kind of a relative scale of what that looks like. Now when atoms become negative ions, they're gaining electrons. Now the nucleus has more electrons to try to keep a hold of. And so it doesn't do as efficient of a job. And so the atoms always get bigger when negative ions form. And notice they get a lot bigger. Chlorine starts very small. It's far to the right. As neutral atom, it's small. But when it becomes a chloride ion, boom, it gets real big. It almost double. It does double in size. Well, almost. It goes from 0.99 angstroms to 1.81 angstroms. So almost doubles its atomic radius. So know what happens to atoms. If an atom gains one electron, it gets bigger. An atom gains two electrons, it becomes even bigger. So the next slide, I'll have you comparing sizes of things. You'll want a periodic table, so you'll be able to see that one or grab one on your folder. We all good with that? Circle the species in each set which has the larger radius. Which is bigger? Magnesium when it's neutral, or magnesium when it's a positive 2 ion? Neutral is right. Yep. Because as soon as magnesium loses 2 electrons, it loses its third row or third energy level of electrons. So now it only has 2 energy levels. It's going to get a lot smaller. So this one has the larger radius. What about calcium versus sodium positive 1?
Calcium.
Yeah, when sodium becomes an ion, it gets real small. And calcium is pretty big in the first place, so calcium would be the bigger one. How about chloride versus bromide? Both in the same family, they both get bigger when they become negative ions. But bromine, because it has another energy level of electrons, is a bigger ion. Yep. Okay, now this one really messed them up last hour. Fluoride ion versus oxide ion.
Equal.
Can't have equals. One's bigger.
Fluoride. Bigger oxide.
Oh.
Which one has the bigger radius?
Oxide. Fluoride. Oxide.
How many electrons does fluoride have? No.
8.
9.
10.
Fluorine, when it's neutral, has 9. Can we agree on that? It's got atomic number 9. So when it gains an electron, it becomes positive 1. How many does it have?
10.
Right, 10. It goes from 9 to 10. What about oxide? How many electrons does the oxide ion have? Why are you saying 8? 10, right. This gains 1 electron, this gains 2 electrons. It goes from 8 to 10. Okay. Yeah, some of you said 8, now you're saying that you said 10.
No,
It's a
but
foul.
because you said oxygen. You said oxygen regular.
Yeah, you said
regular.
oxygen.
Regular oxygen.
I didn't say oxide?
You said oxide.
Oh, I don't know.
Yeah. We got the Aj effect going on. Okay, so anyway, now the question is, this thing has 9 protons holding 10 electrons. This only has 8 protons only holding 10 electrons. Which one is bigger?
Oh.
The one with the wimpier nucleus. Can't hold those 10 electrons as well. That's going to be the taller one, the larger one. Catch that? No? The oxygen, both of them are holding 10 electrons. Fluorine has 9 protons holding on to 10 electrons. Oxygen only has 8 protons holding on to 10 electrons. So the 8 protons are not going to be as good at drawing that cloud of electrons in, so it kind of balloons out like that. So that's the bigger one. What about magnesium ion versus the chloride ion? Magnesium lost 2 electrons. It gets real small. Chloride gained 1 electron. It got big. What you after, Mr. Hubble?
I'm just working on the order. I was just trying to remember what class.
Oh, okay. All right, thanks.
Isn't Florida on the right side, so it's like starting smaller?
It does start smaller, but when it gains the electron, it like doubles in size. So magnesium is going to get small, chlorine is going to get big, so chlorine's going to win on that one. Yeah, if we're comparing the neutral, magnesium versus chlorine, magnesium is bigger. But when they form ions, magnesium gets small, chlorine gets big, and so they kind of reverse the roles.
So when you have an electron, like it doubles like significant.
Yes. Yep. That's what we see. And the values for the sizes are given. Like fluorine more than doubles in size. Just more than doubles.
How do you like how much will get bigger? Like if it was more, 2 even more. Like if they started more photocarbons.
Yep. I would only ask you to compare things like this in the same row. Yeah, in the same row.
Your face will be in mine.
Yeah,
all the
then
time.
they kind of reverse size
Your face will be in mine all
comparison.
the time.
Yep.
There are no questions on this, right?
Yeah, I don't think
No,
there
there
are.
aren't.
Yeah.
There's no what?
Maybe on the question.
On the ionic size?
Yeah, I don't think
There are questions, though. I was just answering one. Number 110, I think.
Oh, I'm not there yet.
Oh. Andrew?
Really bad.
Yep, hold on. No problem. So, yeah, they do ask about increasing size comparing elements, not ions. But look at number 110. In each of the following sets, which atom or atom has the smallest ionization energy? Atom or ion. So take a look at D. Which one would be, we're looking at the smallest ionization energy. Which one is the easiest to remove an electron from? Sulfide with a -2, sulfur when it's neutral, or the sulfur +2 ion. Which one would have the easiest ionization energy? Which one's the easiest to remove an electron?
-2. Negative. Yeah. Negative.
I think to answer the question, you have to understand the sizes. Sizes of these ions. Sulfur is far to the right, so it's pretty small.
Yeah.
Sulfur with a +2. What happens to the size of sulfur when it's a +2?
Small.
It gets smaller. Loses 2 electrons, it gets real small. Now it's got 16 protons only holding 14 electrons, so it gets small. Sulfur with a -2, whoop, it gets big. So it's the sulfur with a -2. Because it got bigger, that nucleus can't hold the outer electrons as well. That's why it got bigger. And therefore it's easiest to remove an electron. The bigger an atom is, the easier to remove an electron from, right?
I thought because it like lost 2, it would only have 2 in the orbital, in the orbital, so it would be like bigger. I thought that's what you're saying.
No, but it has to do with the ratio of protons in the nucleus to the electrons overall. Anytime you have more protons than electrons, that thing's going to draw the remaining electrons in, regardless of what energy level they have. Okay. So the opposite is true too. When an atom gains electrons, it always gets bigger. Even though you know that sulfur becomes very stable when it has a -2 because it takes on a noble gas arrangement. Still though, because it's bigger, it can't hold those outer electrons as well, even though it's very stable for it. That one would be the easiest to remove an electron from, even in all its stability. You okay with that? And that's because of its size. It's big, and the electrons can't be held as tightly to the nucleus. That's what ionization energy is measuring. It's measuring how tightly the electrons are being held on the atom by the nucleus. Since that's big, the biggest of the 3 terms, that's going to be the one that's easiest to remove an electron from. It takes the least energy. So even though there aren't questions comparing sizes, it does still ask it to know something about the size, like that. Okay, now Andrew, is it this?
Yeah.
Magnesium ion and chloride ion. Magnesium ion, you have 12 protons, only holding now 10 electrons. That's going to draw those in because you've got more protons than electrons. For chlorine's going to have 17 protons, and it's got 18 electrons. So now this has more electrons. So when an atom gains electrons, it gets bigger. When this atom loses electrons, it gets much smaller. So because they're in the same row, they kind of reverse their size role. Magnesium before was bigger because they get smaller as we go across the row. So magnesium neutral is bigger than chlorine. But when they make ions, it's going to be the opposite. Magnesium suddenly is real small, chlorine suddenly is real big. Now chlorine's the bigger ion than magnesium.
How do we know when the magnitude grows?
Just know that the size changes by a lot. And so it's a big difference. Magnesium is going to get much smaller than it was before. Chlorine gets much bigger, so now chlorine's bigger. So assume that those differences are big differences, so that when you're comparing something that becomes positive, something that becomes negative, assume the negative one, the gain electron, is going to be bigger than the positive. That's safe. Right?
Well, you have a question like this on the quiz.
Well, the quiz comes from the assigned problem, so...
So, like, if so, how would you get the 10 points? Would you have to, like, explain it?
I might give you these 5, and each of them is worth 2, and so you just get the 2 or you get none.
Oh,
Okay. Which one is bigger?
You have to get 0 and 10.
Yeah.
Okay.
Them all mixed up.
Now I just have one other topic to talk about. Before I have you look at this, there is one topic in the curriculum for this course that was never dealt with or acknowledged until they changed the course last year. They decided, the College Board decided, that they thought photoelectron spectroscopy suddenly is important enough that we should put it now on the AP exam.
What are you doing? She's getting the
Now, photoelectron spectroscopy is a way of removing all of the electrons in an atom. You just strip them all off, and the different energy levels of electrons require different energies to remove the electrons from them. And so that's what, when you're going to get a spectrum like this, like some output that looks like this with spikes on it, and there's a couple of things that you need to know about all PES, photoelectron spectroscopy, data. One of the things you need to know, and this is weird, is what the x and y axis have. On the y axis is the relative number of electrons. So the size of the peak, they don't tell you exactly how many electrons, but you have to compare sizes of peaks. The second thing is the y axis has binding energy. Binding energy means how tightly the electrons are held on the atom. Binding energy is going up as we go left. If there was one thing I wish that we could change about it, it's that. Why do we have to go up as we go left? Well, I don't know. Or this is beyond the College Board. This is research of chemistry, guys this is what PES data looks like. So we can't blame the College Board for that.
So people way smarter than us?
Yes. Yes, right. And there's a reason for it. But it's not convenient when you're first learning about it. Now, what this would show is it's going to show how much energy is required to remove the different energy levels of electrons. And what's important to note is that I would write this down if I were you. Out here on the right, where the binding energy is low, these are electrons far from the nucleus. Since the binding energy is going up, the farthest left peaks, those are the electrons that are closest to the nucleus. Those are the ones that take the most energy to remove. So over here we have electrons that are close to nucleus.